Alrighty, so that's kind of the basics of this. We're going to be doing is we're going to start modeling um, uh, commercial shell and core building, and then later on, if we have time, we might add um, some tenant improvements in there to kind of get you an idea of how then they would have to reference the tenant improvement drawings, and they'll have the core and shell that we've already done, and then you'll add the tenant improvement plans on top of that. Um, so if everybody could, as everybody have Revit installed still, I assume they could open up Revit, and we're just going to get some stuff set up in Revit. So as you're opening Revit, also if you could download this Revit project template from Moodle and this Revit 30 by 42 title block. And those are the two we're going to use for this term. Last term we used a 24 by 36 title block, which is usually on smaller buildings, but we'll go to a bigger title block since we'll have a multi-story building here. So 30 by 42 is pretty common, and then 36 by 48 is the biggest I've seen, architectural speaking. So once you get those downloaded, just let me know. And as you guys are downloading those, also here I have for your use is this. It's a commercial plan checklist that I downloaded from the city of Albany. So as you would be doing your drawings, you would fill this out with your plan review, and you'd put this together with your drawings. And they actually have a checklist here of all the sheets they're going to want to see with their drawings. They have the same kind of checklist for residential as well. And so these are the drawings that we're going to include for this term. We have a cover sheet with the vicinity map. I'm going to use a site on LBCC for our site. So we're going to kind of plan our site as though it was going to go on the campus. Then your plan index, which that's pretty self-explanatory, just a sheet of index of all your sheets. The code summary, we're going to pull from this code. The code summary, and I'll show you an example of that. The code summary is basically what they'll want to see, what codes you're referencing, and all everything that applies to this project. So and I just put check boxes in there to show you which ones we are going to be using. And so here's an example cover sheet. So what they want to see is they'll just want to see what code you're using. And I want to make sure that it's the correct code for what their building department requires. So in the plan review process, they may mark this up, and if they've updated, which I believe Albany, they're updating to an OSSC 2021, I think, this year. So the 2019 code is out of date, but it also it depends on when you've started the project, based on what code they'll require. And so some of this other information on here as well. Here's the vicinity map. So So they'll want the vicinity map, they'll want the index, a sheet list. And here's the building code summary, which is the occupancy type, which we'll find in the code here. So if you go to the chapter 3 of this code, they have all the occupancy classifications depending on the building, and a description of what building belongs in each occupancy. So we'll need to put that on the cover sheet. A description on the project. There's a construction type, the number of stories, the total building area, and then some other information regarding the fire sprinklers and egress, which is how to get out of the building. So building egress is how, in an emergency, people would get out of the building. So you have to plan for that. So also on here, they have a deferred submittal summary, which you can see they put on here because we're not really. This is just a sample project. We won't be adding deferred submittals because, as you can see here, so all the fire sprinklers would be deferred, fire smoke alarm, storefront, awnings. So anything that somebody else has to do. So the architect will define what they want in their building, and then they'll get engineers to do the mechanical, the electrical, and the plumbing. Here they have a storefront system and awnings. So basically they'll draw a awning or a storefront system, but then somebody like Connier Windows or some steel shop would provide a deferred submittal for the any additional parts that the architect didn't provide. So let's say they turn into the city this set of drawings and they've got these steel canopies and awnings that they're showing. They would need to, before they could build those, whoever is responsible for doing the design of the awnings, they would also need to submit a set to the city for approval. And the city would go through their plans and then approve them based on that submittal, so that the architect doesn't have to include that in their contract drawings. So also on this list too, they have a site plan, which we'll do a site plan, but we're not going to do a grading or erosion plan. Geotechnical report. I'm guessing you probably talked a little bit about that in your surveying plan or your surveying classes, but basically there's an engineer that will test the soil to see basically what the soil is comprised of and then what you need to design to support your building. So if it's so like at the campus, it's really swampy, kind of wetlands kind of stuff. So I worked on a project over there, that Sedici's Pizza over by the campus, with a lady who used to work at an architect office that I worked at. She went on her own and she designed that Sedici's Pizza. Well, that site was really, the ground was not great for putting a building on. So they had to put really deep cylindrical concrete piers in the ground to support the building. So there would be really deep concrete piers with concrete footings on top of them, and then the building would be supported by that. So a geotechnical engineer would tell you in the report what the requirements would be to support the building on that kind of soil. And so some of this other stuff we're not going to do, but we will do most of this architectural stuff, floor plans, which we did last time, your sections. Here's something that you typically don't do on a residential, which is accessibility requirements, which on a residential building, I don't believe you are required to plan on having your house being, you don't have to have grab bars and ramps to get into your house because it's a private residence. So some of these things don't apply. Obviously, they'll make houses that are ADA or accessibly accessible. But for residential, you don't have to necessarily do that. But for commercial, you have to comply with all of the ADA requirements, which ADA is it's abbreviation for Americans with Disability Act, I believe, where they say basically they have, we can actually look at section 11 here, which will go over all of the different requirements for your stairways, your having an elevator, having ramps, your bathrooms have to be ADA accessible. And so they require, when you submit a commercial set of drawings, that there'll be diagrams showing all of the different accessibility requirements. Let's look at this kind of example set here. So here she has 2 sheets of accessibility details. And so it basically shows like the minimum requirements for turning in a wheelchair, heights for storage and shelving, even treads, because if they need to accommodate stair treads not being, for an elderly person, so they wouldn't trip, so they have to be a certain way so that they comply with the code. Here's a reach diagram so that that you have to have a certain amount of distance and a certain height for your countertops that are accessible for people in wheelchairs. Here's accessibility routes and just wheelchair alcoves. And so all of this kind of stuff you will need to provide in a set of drawings, and we'll go over some of those things and we'll add them to the sheet kind of to get an idea that when you're working on commercial buildings, you need to think about some of these ADA requirements. Here for doors, there's a minimum door clearance so that you have to have 18 inches on the interior side and 24 inches on the exterior side, depending on the pull side of the door. And so we'll go over all of that as well. And there's I believe it's the first chapter in our book. We'll start going through some of the other chapters. We skipped a lot last term because a lot of it wouldn't really apply to a residence. So we'll go over all the accessibility requirements. We'll try to get some interior elevations, probably of our core and shell bathrooms. Exterior elevations, as you're familiar with, roof plan, reflected ceiling plans. So fire rated construction details. So on a residential building, on a home, I think there's not a ton of fire related construction things that you have to worry about. Obviously it has to have fire blocking in the exterior walls. And there is some code requirement for that, but most of the time it's pretty basic. But in commercial, because it's a space occupied by the public, they have a lot of different types of rating details. So for instance, if we, in our elevators and our stairs, they typically have to be a 2-hour fire rated assembly so that if there's a fire, people can get out of the building. Another thing for the fire rating too, or some of the fire and accessibility requirements is stair landings have to have I can't quite recall what it's called, but basically they have to have the landings have to be big enough. So if somebody in a wheelchair can't access the elevator during a fire, there's like a place that there's room enough for them to be in the stairwell waiting for somebody to help them out of the building. So also we have the energy code compliance, which we're not going to do. Door schedule, glazing schedule, we'll do some of that. We did some of that in residential. The hardware plan, I don't think we're going to do. So the door hardware would just be specifying all the different types of hardware for the doors, obviously. So like certain doors won't have locks, certain doors will have only a lock on the exterior, but never lock on the interior. Office doors might lock on, lock on both sides. All of the exterior doors and any kind of egress would have to have panic hardware, which would be like the push bars. So if you're exiting a building, the door has to be able to push freely open, unlike in a house where it opens inside. A commercial building will need to open to the outside. And it'll have to have a push bar so that in an emergency, if people are panicking, just like the name implies, they can just push on the door, and then they don't have to worry about it not, any resistance. Also, with some door hardware in a commercial building, ADA requirements require a certain, I think it's like a certain amount of pounds of force to be able to open a door. And I think it's 5 pounds, but I'm not quite sure. We'll look at that when we look at some of the ADA stuff, so that, anybody can be able to open the door. Does anybody have any questions so far? We've just been kind of going on. Is everything making sense? Or do I need to cover anything again as we're going through this? Is everybody awake?
Awake, yes. I guess I'm sure some of this is just going to come up more as we get into like the specific modeling and creations. So like obviously when we make our floor plans, we have to figure out where stairs and doors and stuff are going to go. And then the interior, like let's say space around a door would be determined at that point.
Yes. Yeah. And we'll have to just take into account there. And I can also show you how most architects, when I've, in their models, will have a dashed line representing that clearance space. So if we were to look at, let's see, this dashed line, often they'll have those on their doors anyway, so that, and I'll show you how to add those into our door families. We could probably find one that's already made. It doesn't look like they have any of the door clearances on here, which isn't required. Most of the time that's just to help. So as the drafter is laying out, they can remember, oh yeah, I got to keep this door, so far off of the wall. And then, so yeah, see, they just kind of show in here some of the clearances in their bathrooms as well as on the ADA sheet. Yeah, and typically they'll show that outline here. So yeah, we'll go over a lot of that once we get down into it. Also, so last time, as we discussed, we all did our own house plans, which I think it was good. And I think it was kind of fun too, actually, to see all the different houses you chose. But it does create several different problems as far as everybody's house is going to be different. A lot of similar details, but if I'm doing a video on the house that I did, which I guess will be the 13th house, then it might not be necessarily applicable to what you guys were doing on your houses. So for this term, we're going to work on a building together. So we're going to create a core and shell building together. So you won't have to worry about figuring out your individual issues that you might be having with your house, because we'll all be doing it together. So I think that should be easier and help to better learn the software and some of the things that we're going to try to learn, so that we're not trying to basically overdo it. So I'm hoping to get through this a little bit easier this time, especially we won't have any issues with the couple weeks of software woes we had last term. So I think that'll be good. We'll all work on the same thing together. So I think that's going to eliminate a lot of the problems that we might have been having last term. And then, so this term will also be different. And so for a residence, typically all the drawings are in one package. The architect will probably handle most of it. They might even do some of the structure, because from what I understand, the architect under a certain square footage can design the structure. Most of the time they will have an engineer look over it. But for commercial, typically the drawings will be separate, and large residential too. You'll have an architect that will do the exterior or the architecture part of the building, and then you'll have a structural engineer that will design the support structure, and you'll have a mechanical engineer that will design the ducts, electrical engineer, and plumbing engineer, and so on. And so we're going to do that here in this class as well. So we're going to have two different models. We're going to create a architectural model, and we're going to also create a structural model. And when you do that, it's good to link them into one another, so that when you have your architecture model, you'll link in the structural model, so you can see where all the beams and the columns, any brace framing, shear walls, any of those things, where the slabs are, slab thickness, because they're going to design all that. So similar to AutoCAD, where you have an external reference, we'll have an external Revit link of our structural model. But we're gonna create both, because, and then we'll link our structural model into our architectural model. So we're also going to provide a small set of structural plans as well. So kind of concurrently, while we're doing our architectural model, we'll kind of switch over and lay out some columns, our floor, our beam systems, and we're going to create a structural model, which will also have, similar to like last term where we had a kind of framing plan, foundation plan, and whatnot. We'll have the same thing, but it'll be in a different drawing set. And so in here, it'll be much smaller, because we're probably going to focus mostly on the architecture, but just to get you an idea of how they work together in the field. You'll typically work either for an architect or a structural engineer in construction, and you'll have their model to link into. So, and the same thing with any of the other trades, they'll be using the models. You'll want to reference, you don't want to design in a vacuum. So the kind of nice thing about Revit is that they're pushing a cloud-based system so that they can have all of your drawings uploaded to their BIM docs or their BIM 360 glue, which are some sites that they use. And so as your structural engineer, your mechanical engineer, they're designing, they're uploading the models, and then they can load the Revit models into your architectural models, so that you can kind of see somewhat real-time information as it's being changed and updated and populated. So for the structural information, we'll be going and looking at getting a structural cover sheet, foundation plan, floor plan, roof framing plan, elevations, and structural cross sections. Some of this other stuff, again, we're not going to do, because we would have to make up too much. It's just not really worth it for us to make up information that we would actually need to get from an actual engineer on a specific site. So, and then although I would like to do in this class, getting a mechanical and plumbing and our electrical information, getting those modeled in, I just don't think we'll have time to hit everything together. Often I found that still a lot of the MEP trades, so the mechanical, electrical, plumbing, they're often shortened to MEP. They're still using, they're often using AutoCAD, MEP, or a different software for their mechanical drawings. I've been on some projects where they've required them to use Revit so that they can have everything linked together. So there's been a couple projects, but most of the time they're using a Autodesk MEP instead of Revit for that. So if you guys get are out in the field and you happen to get picked up by a mechanical or electrical plumbing engineering firm doing drafting, often we'll probably won't be using Revit, but you may. I'm not sure exactly where the industry is going on that side, but for structural and architectural, they're typically, everything I'm seeing now is in Revit for the most part. So let's see. So that's kind of just an outline of what we'll be doing. This commercial plan review checklist is on Moodle so that you can look at that and kind of get an idea of what plans we're going to have. I also added this Revit shortcut key list. So I exported the shortcut key commands, or actually, no, I got this from the Autodesk website and kind of created an Excel spreadsheet that I uploaded to the Google Drive so that if you want to know the command shortcuts, here's a list of the most common Revit shortcuts. You can organize this list. It is an Excel document, so you should be able to download it as if you have Excel. But I think it also works here in Google Drive or in the Google Sheets. So you can, if you're looking for some shortcut key, if you'd like to use shortcut keys, you can organize it by A to Z. And I believe you can, in Excel, there's a little bit better, let's see. So if you have Excel, when you hit these little arrows, you can actually filter. So if you're trying to find a specific command, it might be easier to, like if you're looking for trim, it will show you, and you can find pretty quickly the shortcut command for trim by using the filter tab here up at the top. And so if it's in a table like this, you can select a little button and kind of search through and turn off and on everything that you want to hide or see. In Google Drive, if you don't have Excel, there is some functionality like sorting, but I'm not super familiar with the Google Sheets to see if you can actually get any more information, kind of sort the information better on Google Sheets. You can always do Control F to find any commands you want to see on here. In Revit, you can go to the View tab, and then you can actually go to your keyboard shortcuts to try to find your commands as well too. So I have that on Moodle, and some of the stuff I had last term I put on here as well. The quick, kind of something that outlines the quick access toolbars so that you can see what they do quickly and not have to try to find and search for commands on here as much. And then another one here on printing, because I noticed a lot of times I was still getting prints that weren't to scale. So here's a sheet that shows exactly all the different the way to set up your print so that you can print to full size, except for this this term will be 30 by 42 instead of 24 by 36. That will be the only difference. So if everybody's ready and has Revit open and downloaded these two templates, we can get started it's kind of setting up our project. So if you open up Revit, hit new, and then it'll bring up this new project browser. You can either choose one of these, but I'm going to have you browse out to wherever you saved the file you downloaded. So I keep my Revit files just on a folder under architectural design and Revit files. And then I created a folder for templates. And this is the architecture project template. Does everybody have that? So once you find that, browse out and select it. Go ahead and hit open. You'll see that it'll be named there. And then hit OK. And the reason why I'm doing it this term is that in some, I think I had this for last term, but I noticed still sometimes when I'd look at your drawings, the detail level was still set to coarse instead of fine or medium. And so this template, everything's set to the detail level to be medium. And any new drawings that you make, so if you were to come up here to the quick access toolbar, or if you were to go to view and cut a new section, if you were to right click and go to view, this new view will be set to medium so that you don't have to worry about setting that every time. Is everybody with me? And got the new
so far.
And got the new template.
Yep.
Awesome.
I have it downloaded, but Revit did not want to open it, so I'm still working on it.
Okay. Are you in 2021?
Yes, I think it didn't like where I had it stored.
Oh, okay. Yeah, I think if you have it stored in an external drive, actually, I don't think that should matter, but I don't know. Sometimes Revit can be picky, or most software can be picky about where things are at. So realize, since this is your first, or pretty new to Revit, this is kind of the main screen that'll open up. That usually opens up level 1. The template, what it did is when you open a default template from Revit, and I'll just do that real quick while everybody's, so if I go to new, just choose one of, the architectural ones that are default Revit. One of the things I just don't like is that their view bubbles are square, and then all of their detail level, which the detail level, kind of a reminder for everyone else. And so the detail level, what that does is, as you can see, this wall looks pretty plain because the detail level here at the bottom, or over here on the properties palette, there's 2 palettes. The properties palette, and then the project browser, this is where all of your drawings will be located. And the properties palette is similar to in AutoCAD, where you have hit Control 1 to get your properties up, and it'll tell you information about whatever element you have selected. So if on your properties palette, if in your drawing at the bottom, there's the detail level, and it's also located on your properties palette. And so if you change that to medium, so the default templates are set to coarse, which doesn't show very much information. But if you set it to medium, it shows all the layers of the walls. And then if you set it to fine, depending on the element, it will show more layers. So for instance, if we were to draw a beam or a column, so I'm going to set it back to coarse, and I'm going to draw a column or model a column. So when it's set to coarse, all we see is line work. And if we set it to medium, we see a squared off column, but in reality, the column is actually has the radiuses at the bends here at the web. And so if you set it to fine, you can actually see all of the different features of the column. So on coarse, on the detail level, you just get line work. Medium, you get the just this kind of a rounded off or a squared off column. And fine shows kind of what the column would actually look like. And so each element is different. Some elements don't have any change. That's set up in the family, but we'll get into that. Did you guys create a family in your customizing AutoCAD classes last term?
We did, yes.
What did you do?
I
It
did. I
was-
think I did furniture.
Yeah, it was left up to us.
Okay, so that he just showed you how to use and set the parameters, and then you created a family.
Yeah.
Right.
So what did everybody make?
I made a dining table. You could change the size of the table itself and the size of the legs as well as the center column.
Okay, cool.
I made a
I did a
wall
chair.
shelf.
Different sizes, heights. So like little kid table and then like countertop.
Awesome. Anybody else? I heard somebody else talking in there.
I did a wall shelf and I have two support. I had like the main shelf piece and then two supports underneath. So I had it. So for the distance, the length out from the wall, and then how high it was from the top of the shelf to the bottom of the supports, and then the support distances from the outsides.
Cool. Did you guys enjoy that? I love, actually, I really like making dynamic blocks and families. So
Once I got Rivet to cooperate, it was fun to make.
yeah, that's pretty common, right? So that's kind of the difference between the two, the default template and then the template I just had you guys load in. And so that's why we're doing that. And so if everybody has that, the next thing we'll do is on the view tab up top here, we'll go to sheet. And once you select sheet, go ahead and hit load. And then wherever you saved that 30 by 42 title block, you just want to browse to the title block, wherever you save that, and then select that title block. And hit OK, and it'll load that title block in. And so once you hit OK, it'll create your first sheet in your drawing. And as you guys know, it'll create on the project browser under sheets. That's where you'll find your first sheet. And while we're here, and I don't think I ever covered it last time, I think I noticed some of you got it and just figured out how to do it, but I'll go over how to change this information. Let me know if I need to slow down or stop, or if you guys are having any issues and need to catch up. So if you were to double click on your title block, or select your title block and edit family up here at top, sorry. So once you select the title block, the modify tab will pop up with this edit family option. And you can either double click on the title block itself or any family, or on the modify tab, hit this edit family button. And it'll bring you into actually all the information for the title block. Now, the only thing we're going to change here is your name. And so this is pretty easy to do. You know, zoom in to find the text in the title block that says student. Double click on the text to enter into the text, and then change your name to whatever your name is. So once you've done that, you can load into project and close. So you'll just click load and close. You're going to say yes, because this is the title block that's going to be on your desktop or wherever you've saved it. And you'll want to say yes, replace existing file. And overwrite the existing file. And then you can see it's going to change. It works just like a block. A family is essentially the AutoCAD block. And so this, anytime you create a new sheet, this will be on each sheet. And while we're here, let us also just set up our project information. So if you go to the Manage tab, you can either any fields that are able to be editable on the title block. If you select the title block, you can kind of hover over and see which ones you can click into, or you can go to the Manage tab. On the top bar here, hit Manage and go to Project Information. And your title block is reading all this information. So owner, we'll just say is LBCC. I guess we should do Benton. Address. We'll just use LBC's address. I don't know what it is. $6,500 Pacific Boulevard. You can click on the little ellipses next to the project address and just paste that in there, or enter 6500 Pacific Boulevard, Southwest, Albany, Oregon 97321. Project name, we'll just call it architectural. I don't know, what should the project name be? We'll just call it. We'll just call it Core and Shell Building. And project number, we'll just call it 463. So once you get all that information entered in there, it will update your title block. This checker information isn't really necessary. Author would be you. Issue date, we don't have one yet. well, it'll be the end of the term, and you can see it populated the project number, the project name, and then these other two are just the sheet name and the sheet number. So once you get that all done, I want you to go ahead and hit save. And then the one thing I'm going to do this term that I didn't do last term is I want you to, I'm going to have a, so when you get in a company that you're at, they're going to have a naming convention. So they're going to have how you want to name, how they want you to name their drawings. So for example, for my work, they have a very specific, they want the project number for the first 5 digits, and then the sheet number for the last 3. And so every project you go into, it should be, oops, these are all, that same naming convention will hold over for every single project. So no matter what project you go to, you'll have that same naming convention. And so basically that's what we're going to be doing here is put EG4.463 underscore your last name underscore your first name. And then our first model will be the architectural model. So once you've done that, it'll change.
Nah, I didn't get it all.
Okay, let me go back.
Okay.
Alrighty. So we'll save over that, and then it'll change the name of your model, and then you'll do the same thing again. So once you've done that, go ahead and hit save as project. And then do the same thing, except call it structural model. So we're going to start off with 2 models. I'm not going to save over mine because I've already done some stuff in there, so I don't want to lose all that. So once you've done that, if you're open up that sheet we created, and then go ahead and go to print, which if you go up to file, you can either do Control P to do print, which is pretty common for most programs, or you can go up to file, down here towards the bottom is print, and then select print. So does everybody have Bluebeam set up for their printer?
I do at least.
Okay, good. So just like we did last time, I want to set up. Down here at the bottom right, you go to setup. change this to, so the under print setup, right underneath the name, there'll be paper size. And you're going to change that to 30 by 42, which is architectural E1. And there it is. Select architectural E1.
What if you don't have that?
Do you have Bluebeam as a,
Oh, never mind. I found it. I was looking under ANSI.
oh yeah, that'll be for, yeah. So yeah, architectural. So yeah, the architectural E1 is, the 30 by 42 sheet is different. They don't actually have an ANSI one. So architectural E1 for the 30 by 42, offset from corner. Make sure and have zoom set. So this is what makes it print to the full size. So if you have center, it will print, well, if you have fit to page, it'll fit everything to page and center it, but you'll want to have it offset from the corner and then zoom to 100%, and that'll give you a full scale. And under these options, make sure hide reference and work planes is checked. Make sure to check. Go ahead.
On that offset from corner, do you want it to say printer limit or do you want it to say no margin?
Printer limit is fine. And then hide scope boxes and hide crop boundaries. So if you have a section cut on your plan, but it's not on a sheet, that's what an unreferenced view tag is. So it won't print those. And then if you forget to turn off your crop boundary, which I like to have them turned off, this one will hide it even if you go to print it. And then for appearance, color, high is fine. Make sure I have vector processing and landscape. So then the next thing I always do is I hit save. So my default one is set to that. And then I always hit save as well and just call it 30 by 42 color. So once you've got all that information set, I'll leave it here for a little bit and let me know if you've got it.
I got it.
All right, now it's all set up, and then you can do a preview. Always, before you print your drawings, you should always do a print preview so that you can see what it's actually going to print, and you can catch it before you print it, particularly if it's a large drawing with lots of shading or lots of detail that it will take a long time to print. It's good to do a print preview so that you can see that it is printing correctly. And so it looks like it is. In Revit, so in AutoCAD, if you hit escape or close, it will bring up the print dialog box again. But in Revit, if you hit close, it actually just closes it. So you'll want to hit print, which will bring back the print dialog box. And then I believe, let's try something here. I'm just going to hit cancel. Then I'm going to hit print again just to make sure that's saved. I think it should have saved it. And it did. So all of our settings are the same. It's all set up. Now, so the next thing we can do, so when you turn in assignments, I'm going to hit OK here. It's going to say just project 1 because that's what it is. That's what mine is. But here, let me open my other one. So, but since I have it now named a structural model and an architectural model, if I were to hit print, it's going to name it the name of the architectural. It's going to call it the class name, my first last name and first name, structural model. And so that'll be a lot easier. So I know whose PDF you've uploaded, and that'll be an easier way so you don't have to type it in every time. And same too, so if you go back to print, I'm sorry, I'll go, if you go up to print, that's just current window. So it's just going to name it after the whole project. But if you select selected views and sheets and hit select, so when you do that, you can select all the views and the sheets in the project. I always hit uncheck views because I just want to select just the one sheet. Hit OK. It's going to ask if you want to save these settings. You would if you're printing a lot of sheets, but I'm not. I don't want it to save this, so I'm going to hit no. So it'll save your sheets. So you hit OK. It's going to ask you, you have chosen to print one view, because I did a separate files, which is what I wanted to do. And I hit yes. And because I had selected a sheet, now it's going to name it just structural. Here, we'll go back to the beginning. It's going to name it the same class, first, last name, structural model, and then your sheet number and the name of the sheet. So if you print an individual sheet, it will actually give you a sheet name. So last term I was having you print, the floor plan to review, or the roof plan or the elevations. Now, since you've named your model, the class name, the class number, your name, and what it is, and if you put individual sheets the way I just did, it'll automatically name it whatever sheet it is. So if I called it A101 floor plan, it's already going to name it that, and that'll be an easier way for me to keep track. And it'll also be a good way, because when you're in an office, whether you're working for a steel detailer or a cabinet maker, or if you get a job working for even a mechanical, if you're going to do parts and working for a machine shop or what have you, they're going to have naming conventions that you'll have to do every time, and they'll be pretty particular about it most of the time. So it's good to kind of get in the habit to make sure you have everything named. They usually won't have your name, but you'll have the project name, project number, and then a sheet description. So so now we got those set up. Let's see. So one of the things, I know a lot of you guys were interested in civil drafting. That's right? A lot of you guys are wanting to go into that field, if I recall from last semester. Or is that not true?
There are a number, yes.
So as I was doing research for this term, I found this site, which I actually ended up having to use I couldn't get access to a Lynn Benton campus civil plan. So ideally, if you're working at an architecture firm, that your civil engineer is going to have have the site surveyed, and you'll get a nice survey plan that's going to have benchmarks, and it's going to have the topographical information. It's going to have coordinates. It's going to have your plot lines and all of that kind of stuff. So it's nice. That's, as an architect, you're going to want to start working from that. But this CAD Mapper site, because I wanted to start with some actual topography. And I can put this link on the internet, on the Moodle as well. But if you go to this CAD Mapper, you can export a DXF file or a SketchUp file, or Rhino, or even an Illustrator file, it looks like, of any site anywhere in the world, really, I think. And so I did this for LBCC. So this is what we'll be using for the class. We're going to start with this site that's going to give us kind of an idea of kind of what the topography is for our site out at LBCC. And you don't have to do, well, we're going to do this later. But just to give you an idea, we're going to start with that, and we're going to, once you've gone to this, I'm actually not going to have you go to the site. You have to log in. It's actually free. So it's free for up to, so if you wanted to get a bigger site, but it's a free up to 1 kilometer or 1 kilometer squared. Exactly. So all you'd have to do is go to the site, kind of adjust your window of what you want to print it out, and then hit create file. There's some settings over here. I think I changed the contours when I exported mine to like 8. And so you can hit create file. And then you can actually print out or export out a topographical map or a topographical surface that we can kind of use to base our model off of. And so once you do that, it'll download a DXF file that you can then import into Revit. And so I'll just show you a couple things I was doing in here. So on here, that template we had has a site plan. And so once you've downloaded your the site, and I'll have it on Moodle. If you go to the Insert tab up here at the top. Now, if we have topography from like a civil engineer, that would be ideal. But just for this exercise, it's better than nothing. And then last term we kind of made up our own topography for our house. This way we can start with something that's somewhat realistic. So you'll go to Link CAD. And I have a couple base plans that I got from someone I used to work with that has done projects out at LBCC, but I couldn't get my hands on a site plan, like an actual civil or survey plan. So I can go into this CAD mapper, download it. It downloaded a folder called Tangent Oregon, because that's where I was at. You'll have to change the drawing file type to DXF. Again, I'm just showing you, we'll have a separate video on how to do this. But this is what we're going to be starting with. You hit it open. And then we have our site plan. And the one thing that I forgot is because it exports it in meters, so it's really small right now. So if you've inserted something like this, we can go to Manage Links on the Insert tab, CAD format. I'm going to remove, add. I'm going to select that CAD mapper. It's supposed to be auto detect, but it did not. And then we'll want to change it to meters. Hit open. Okay, and now it's put it. So now we have the site that I exported from LBCC. So once I've got this site.
So did Revit basically just convert the meters to inches and scale it according to what you wanted?
Yes, yeah. So because it was meters in the drawing, it made it real small. But since I told it that the units were meters, it now made it the correct size. Does that make sense?
Yeah. That just seems like that's a lot of math, and it did it like instantly.
Yeah, yeah. Revit's pretty smart, sometimes too smart. So once we can make so I got that imported in, I'm going to hit my 3D button so I can see it in 3D. Now this is a pretty flat site, so you're not going to get a ton of, difference in elevation. But once you've done that, you can select it, go up to the Massing and Site tab, And if you select topo surface, it's similar to what we did, right? But we just placed a bunch of points before. So now we can create from an import. So we can select this. So we'll select this import. It's going to ask us, so when you get a site plan from a engineer, they'll have all of these layers, or these from the CAD file. And so you can select whichever layer that you want to have it create the topo surface. So you typically want to do the topography, any contour lines. They might have streets and other things all in different layers. But you can check or uncheck layers here and hit OK. And now it's going to create the topographic surface for us. So I'm going to right click. I'm going to select this CAD file I inserted, right click, hide and view elements. And now I've got that topographic surface, something similar to what the site at LBCC is. So we're actually going to put our building over here in the corner. So for instance, in a later video, we'll link a CAD file for the site plan that I got. Oops, I think I left it. Yeah, I left it meter. So I told it meter. So I'm going to go up to manage links. I'm going to remove, add, and I'm pretty sure this one will auto detect just fine. And so let's see. I can line up our topography that we got on top of this site plan that I got from somebody I used to work with, and we could actually have a pretty decent site plan to put our building on and work with some topography. So again, I'll go over that in a different video. And the other couple things that I did while I was messing around with this is so I downloaded, or I went and found. So if you wanted to do your own house or anywhere pretty much in the world, you can go on that CAD mapper and then download all different sites from everywhere. Now, LBCC doesn't have, they don't really have a lot of geometry there, but so I went to San Francisco, and let's change that to meters. And so in more heavily dense areas in this CAD mapper, we'll actually export some 3D buildings. Obviously, they're just for reference, right? They don't have any detail on them. But this was San Francisco. I can't remember what this is called. It's over there by the this Walt Disney Museum, just down the road from it, over in San Francisco. And so it actually exported a bunch of houses and things. So it's kind of a neat little program if you are interested in civil stuff and kind of want to tool around this world. You could kind of export a bunch of different places. And so I also did Golden Gate Park in San Francisco. Oops, did I do tangent again?
It looked like you did tangent again.
Yeah. And so here I just did a little portion of Golden Gate Park. And I like this one better just because I had more it had more elevation changes, so it looks cooler when you're doing the 3D topography on top of it. And so you can actually kind of see the hills and whatnot. Hide. Anyway, we'll start with this, but at LBCC site, so that we can build our building in somewhat of a realistic site information. So, and then what else? Oh, back to building code. Let's see. Hold on. Let me look at the. Yeah, so our first test will be on the building code. I have that checklist here too. I know kind of the importance of building code. It came up with a friend of mine who moved out to Pennsylvania from Oregon, actually. And he bought a house that, I mean, it was going to be a fixer-upper, and he knew that going in. But once he got in, he noticed part of the house was sinking into the ground. And so as they started digging up the floor to kind of determine, what the issue was, normally you have to get out there. We had to do it at our office, actually. They get out there and they jack up the building, and then they'll kind of reinforce the foundation and the footing so it stops sinking into the ground. But as they started doing some of the demo, they realized that they actually had, let's see, they actually built the foundation right on the dirt, or they built the joists. So as you can see in some of these pictures, they didn't have a footing. So like last class, we had a foundation wall and a footing, and then they had the sill plate and the joist sat on all that. And you'd want to make sure the grade was underneath and not touching any of the wood stuff, right? Well, they actually built right on top of the dirt. They didn't bother to pour a footing. They didn't bother to do anything. They just built it right on top of the dirt. And so once they got in there, they had to dig all that up, and he had to, obviously that's not good for any of the wood framing. Wood and water don't really mix, particularly structurally. So they had to dig all this up and actually pour footings under there per code. And so that was quite a big project that he found out that he was going to have to do. Got a good deal on the house though, I guess, but had to spend thousands of dollars. So they had to jack up the house. So as you can see in this picture, in these pictures, they actually had to, it looks like they've got, 2x4s kind of supporting the structure, and they actually had to kind of redo everything and then dig it underneath and get enough dirt and so they can get below the frost line and actually dig a footing and a foundation wall. So this is what we were looking at last term, right? That, you know, your section, here's the footing at the bottom. They have the foundation wall. They got their sill plate. And this even looked like some of our houses where we, you know, had to kind of make that building a skirt. And so, you know, they'll put the siding down across the top of that. They'll have a, you know, flashing that they'll have to apply in here. It doesn't look like they maybe have set the building down yet. So anyway, as we're going to this term, I thought that it would be good for us to focus on building code, because without building code, people just build, you know, have the potential just to build their houses however they want, and this wouldn't be good structurally or even safety wise. So as we learn more in this term about how building codes are, then you know, we can kind of learn some of the reasons why that they're there. I know they can be kind of annoying, but they're definitely there for a reason. And depending on what you do, there's lots of different building codes. Let's see. Yeah, I looked it up before. So as you're going through, depending on what, we do a lot of work in California. And so not only do we have to do a lot of work for building codes for just the city. So the city is responsible, the building department is responsible for reviewing all the residential and commercial plans that come through. But in some instances, we do a lot of work in California, and they have what's called OSHPD, which is this hospital building. So any hospitals that we do, not only do they have to go through a building review by the city department, it actually has to go through an OSHPD review as well if it's a hospital. And they also have a DHS for schools. So there's in some places, there's several places that you have to submit your drawings to. So not only will you have to submit your drawings to the building department, like we were looking at earlier in the beginning of the class, you may also have to be submitting your drawings to different agencies depending on what your building is. So if you're doing a school, you would have to go submit your drawings to DHS. And there's also, I'm not positive about it, but I think Oregon for hospitals, you also have to submit your plans to a different agency if you're working in a hospital. So I think for the first class, that's probably good. Is there any? I know I think it was a lot to go over for the first day, but again, we'll go through all of this stuff as we go throughout the next 10 weeks. So we'll go more in depth into the different building code, getting the site in and getting our buildings modeled and linked into each other, and getting our structural framing and details. Is there any questions or anything else that you'd like me to cover before we call it? I think
I got a question.
Yeah, absolutely.
So is this class going to be kind of the same structure as last term, where you just kind of post videos and then class time is for questions, or you want us to actually show up every day, every class day?
I was going to do the same setup as last time, so that class times will be. Is that okay with everybody? I can do it either way. It seemed like the videos worked best for everybody.
Yeah, it worked pretty well for me, and I mean, you were always available if I had questions, so it worked for me.
Okay, yeah, no, that was how I was planning on doing it also this time. Just, you know, watch the videos. If you have questions, come to class with your questions, or if you need, Revit assistance. So yeah, I was planning on doing it the same way.
I had a question as well, not necessarily about what we went over today, but in the email that you sent out for the class schedule, it says that it's every 11 weeks instead of for 11 weeks. So the calendar goes out to like February 2022, Wanted to make sure that that was not what it's supposed to be.
Oh no, that's correct. That's the way that they wanted to do it. I'm just kidding. No, no, I'll fix that. Yeah, I meant to do it for the next 11 weeks, not for. Yeah, thank you for bringing that up.
Yeah, I saw that and I was like, surely this can't be right, but I want to check just in case it is, but I don't know why it would be that way.
Yeah, you got to wait until we finish it all, and then before you can get your degree. Cool. Thank you for bringing that up, man. I will get that changed. Any other questions about anything? Not just what we went over.
So you'll answer any question?
I will.
What's the meaning of life?
What is it? 42?
42?
Yeah.
I think the correct answer is yes.
The answer to the greatest question in the universe is 42.
Uh-huh.
I heard it was 7. Back in middle school, it used to be 7.
Hitchhiker's Guide to the Galaxy.
I was just going to say it's a Hitchhiker's Guide to the Galaxy is the greatest. The answer was 42. Sorry, I just did like a little nerd flex there, I think.
Alrighty, I'm gonna get out of here. Thank you.
Yeah, no problem. That was enough for you.
I got your reference. You're all good.
Okay, good. Yeah, I was a little bit worried. I heard the crickets and I was like, uh-oh.
Yeah, I think my wife had seen it, but I've never actually watched it.
Reddit. You mean Reddit, not watch it.
Yes.
I've read it and watched it.
She's a fan of the actors, so that's why she watched it. She likes the people who played in the movie.
Well, that's fine. But
But now she needs to read it.
yeah,
Okay, so that'll be done for the first week, right? Everybody's got to at least watch or read Hitchhiker's Guide to the Galaxy.
is that in lieu of the quiz?
Yes. The quiz is only 5 questions. It's just to make sure that you go to the website and start looking around on the on the building code.
With some surprise questions from the book/movie.
Yeah, exactly. All righty. Well, I'm glad we had this talk.